The idea of a flat Earth is not new. Ancient civilizations like the Babylonians and Egyptians often imagined the Earth as a flat disk. This view was influenced by their limited understanding of the world around them. The Greeks were among the first to propose a spherical Earth. Philosophers such as Pythagoras and Aristotle observed evidence like the curved shadow of the Earth during lunar eclipses. This led to a shift in thought. The modern flat Earth theory emerged in the 19th century with Samuel Rowbotham. He rejected scientific evidence and promoted his own interpretation of the Bible. Rowbotham's ideas gained a following. This led to the establishment of the Flat Earth Society. Despite overwhelming scientific evidence to the contrary, the Flat Earth theory persists in the 21st century. The internet and social media have provided a platform for these ideas to spread rapidly. This resurgence highlights the importance of understanding the historical context of scientific ideas. It also underscores the need for critical thinking in the digital age. We must be able to differentiate between fact and fiction. This is especially important when it comes to understanding our place in the universe. One of the most common arguments for a flat Earth is the appearance of a flat horizon. Flat earthers argue that if the Earth were a sphere, we should see a curvature on the horizon. However, this argument is based on a misunderstanding of scale. The Earth is so large that the curvature is not noticeable over short distances. It's like looking at a small section of a very large circle. The curve is so gradual that it appears flat to our eyes. Imagine an ant walking on a basketball. The ant's perspective would show a flat surface, even though the basketball is round. This illustrates how our limited perspective can lead to misconceptions. The flat horizon argument is a classic example of how our senses can be deceiving. We need to rely on scientific methods and evidence to understand the true nature of our planet. Another key argument made by flat earthers is their rejection of gravity. They claim that gravity, as we understand it, is a hoax. Instead, they propose alternative theories. Some suggest that the Earth is constantly accelerating upwards. This upward acceleration, they argue, creates the illusion of gravity. However, this theory is easily debunked by basic physics. Gravity is a fundamental force of nature. It is what keeps us grounded on Earth. It is also responsible for the orbits of planets around the Sun. If the Earth were constantly accelerating upwards, as flat earthers claim, we would feel it. We would also expect to see objects thrown upwards behave differently. The fact that we observe consistent gravitational effects on Earth and throughout the universe is a testament to the validity of this fundamental force. Denying gravity is akin to denying the existence of light or heat. It is a rejection of basic scientific principles that have been tested and verified countless times. Perhaps the most compelling evidence against the flat Earth theory comes from photography. Countless images have been captured from space, clearly showing the Earth as a sphere. Satellites orbiting our planet send back a constant stream of data and images. These images leave no room for doubt about the true shape of our planet. Flat earthers often dismiss these images as fake or part of a grand conspiracy orchestrated by government agencies like NASA. They claim that NASA is manipulating these images to deceive the public. However, these claims lack any credible evidence. Independent organizations and individuals from around the world have captured images of Earth from space. These images are consistent with those released by space agencies. The sheer volume and consistency of photographic evidence from space make it impossible to deny the reality of a spherical Earth. To believe otherwise would require an elaborate and implausible conspiracy involving countless individuals and organizations across the globe. The existence of satellites and space travel provides further undeniable evidence against a flat Earth. Satellites orbit our planet, sending signals that enable communication, navigation, and weather forecasting. These technologies rely on the principles of a spherical Earth. If the Earth were flat, the orbits of satellites would be impossible. Moreover, astronauts have traveled to space and witnessed the curvature of the Earth firsthand. They have conducted experiments and observations that confirm the Earth's spherical shape. These experiences are documented and shared with the public. They provide irrefutable proof of our planet's true form. It is important to remember that space exploration is a global endeavor. It involves the collaboration of scientists and engineers from many different countries. The fact that these diverse groups all operate under the same understanding of a spherical Earth further reinforces the validity of this model. Despite overwhelming scientific evidence, the flat Earth theory persists. This raises questions about why people cling to such beliefs. Several psychological and social factors contribute to the allure of conspiracy theories, including the flat Earth theory. One factor is the desire for simplicity and control. The world can feel complex and overwhelming. Conspiracy theories offer simple explanations and a sense of order. They provide a framework for understanding events that might otherwise seem random or chaotic. This can be comforting even if the explanations offered are factually inaccurate. Another factor is the distrust of authority figures and institutions. Conspiracy theories often thrive in environments where there is a lack of trust in government, the media, and scientific experts. People may be more likely to believe in alternative explanations if they view mainstream sources of information as unreliable or untrustworthy. The persistence of the flat Earth theory, while seemingly harmless to some, highlights a broader societal issue: the spread of misinformation. In the digital age, false information can spread rapidly and widely. This can have serious consequences. When people base their beliefs on misinformation, it can lead to poor decision-making. This can be seen in the context of public health, where the spread of misinformation about vaccines has led to a resurgence of preventable diseases. It can also be seen in the political realm, where false information can influence elections and undermine democratic processes. Moreover, the spread of misinformation can erode trust in legitimate sources of information. When people are constantly bombarded with false and misleading information, it can be difficult to differentiate between fact and fiction. This can lead to a general sense of skepticism and cynicism, making it challenging to address important societal issues. Combating the spread of misinformation, including beliefs like the flat Earth theory, requires a multifaceted approach. One crucial aspect is promoting scientific literacy. When people have a basic understanding of scientific principles and the scientific method, they are better equipped to critically evaluate information and identify false claims. Scientific literacy is not about memorizing facts and figures. It is about understanding how science works, how to interpret evidence, and how to draw logical conclusions. It is about developing a critical mindset that questions claims and seeks out reliable sources of information. Education plays a vital role in fostering scientific literacy. Science education should not be limited to memorizing facts. It should focus on developing critical thinking skills and encouraging students to question, explore, and discover. This approach to education can empower individuals to become informed citizens who can make sound judgments based on evidence, not misinformation. In the digital age, where information is readily available at our fingertips, critical thinking skills are more important than ever. We are constantly bombarded with information from various sources, not all of which are reliable or accurate. Critical thinking involves questioning information, evaluating sources, identifying biases, and considering alternative perspectives. It is about thinking deeply and logically about the information we encounter. Critical thinking skills can help us to identify false or misleading information. We can learn to recognize common tactics used to spread misinformation, such as emotional appeals, logical fallacies, and the use of unreliable sources. Evaluate the credibility of sources. We can learn to assess the trustworthiness of websites, social media posts, and other sources of information. Recognize our own biases. We all have biases that can influence our thinking. By being aware of our own biases, we can try to be more objective in our evaluation of information. The flat Earth theory, while demonstrably false, serves as a potent reminder of the importance of scientific literacy and critical thinking in the digital age. The Earth is not flat, and the evidence overwhelmingly supports this fact. However, the persistence of this belief highlights the challenges we face in combating misinformation and promoting a greater understanding of the natural world. By embracing scientific literacy, We empower ourselves to navigate the complex world of information with discernment. By fostering critical thinking skills, we build a society that is more resilient to misinformation and more equipped to address the challenges of the 21st century. Let us move forward, not backward, in our understanding of the universe and our place within it. Let us embrace reality, one globe at a time.